Surface currents are mainly driven by surface global wind patterns such as the trade winds and westerlies. The following is a map of the world's surface currents. Arrows in blue are cold currents. Arrows in red are warm currents. Ocean surface currents are driven by subtropical highs. Currents flow poleward on east edge of ocean basin and west edge of continental. Currents in black are neither cold nor warm since they flow from west to east. Whereas deep ocean currents are driven by density differences, which are driven by temperature and salinity differences. Salinity is the measure of how much salt is dissolved in water. Deep ocean currents begin near the poles. In the north, there is the North Atlantic deep water which forms in the Labrador and Greenland seas. In the south, the Antarctic bottom water forms near Antarctica. The North Atlantic deep water flows southward through the Atlantic. Antarctic bottom water flows beneath it near the ocean floor since it is much denser. Deep waters mix and are funneled eastward by the Atlantic circumpolar current. The deep currents gradually rise due to upwelling, as discussed in the previous episode, where there is return flow by the surface currents discussed earlier. This is called the thermohaline circulation, where thermo is the root word for temperature differences and haline deals with the salinity part. It is the global ocean conveyor belt that distributes heat globally. Climate change can have global consequences to this conveyor belt. Melting polar ice caps and warming surface waters will reduce the temperature and salinity gradients and thus weakening the thermohaline circulation. Thus, less heat reaches the poles, and heat stays at the tropics, drastically having long-lasting impacts on climate. Can you guess the fastest ocean current in the world?